Hello, today we have this problem. I initially thought it was going to be complicated, but it's actually fairly simple. So we have two curves in RK, gamma 1 and gamma 2. Gamma 2 is defined as a composition of gamma 1 and phi, where phi is a continuous one-to-one mapping of CD to AB, such that phi of C is equal to A. And we have to prove that gamma 2 is an arc, a closed curve, or a rectifiable curve, if and only if the same is true for gamma 1. I have to show that these curves also share the same length if they are rectifiable. Alright, so how do we begin? Well, first of all, it is important to review the function phi. We know that phi of C is equal to A, and for this proof, we need to show that phi of D is equal to B. But how do we do that? Well, phi is a one-to-one continuous mapping and also on 2. So it's injective and it's surjective. And that's important to note because that implies that phi is monotonic, strictly monotonic in fact. And since phi of C is equal to A, then the following values can only be greater than A. So phi is monotonically and strictly rising. Therefore, phi of D is supposed to be equal to B. Alright, but how do we show this fact? Well, I didn't see it really prove it, although I'm really sure that in most of analysis books that's an important part. The fact that if function is continuous one-to-one and then 2, then it's, well, supposed to be strictly monotonic. So how do we show that? Well, suppose we have some number here, x capital, and suppose it lies between A and B, and suppose that there exists x1 and x2 such that x1 lies between A and capital X, x2 lies between capital X and B. Okay, I'm being stupid, not A and B, and that's C and D here. Oh my god, why am I so silly? Right, so C and D. And let's say that both x1 and x2 are gonna have values at phi less than capital X. If values like this do not exist, if there is not a single capital X like that, so we are implying that suppose that capital X exists like this, such that there exists x1 and x2, such that both of them are lesser than x, and they lie in these two ranges. Well, now I'm gonna show that that's not gonna be exactly possible because, first of all, let's take the maximum of phi of x, or x belonging to the set consisting of x1 and x2. Alright. Now, what we can do is, since we know that phi of x1 is less than or equal to phi of x, let's call this y, yeah? Less than or equal to y, yeah? Less than or equal to phi of x capital. Here we can also introduce x2 like this. There exist numbers, let's call them t1 and t2, such that, actually no, they don't even like, okay, notice that phi is a continuous function. Therefore, there should be, if we were to take some value z, let's pick arbitrary z, such that z lies between y and phi. Also, y can be equal to phi of capital X, or else the function is going to be 1 to 1. Alright, so let's pick z like that, and there should exist t1 and t2, such that phi of t1 is equal to phi of t2. t1 belongs to the range from x1 to x capital, and t2 belongs to the range from x capital to x2 due to the continuity of the function, but this contradicts the fact that we're working with the one-to-one function. So, alright, we have proved that it's strictly monotonic, which also implies this equality and the fact that it's strictly increasingly monotonic. So let's put this aside. Now applying this, we can safely say that y2 is going to be closed curve if and only if of f, if and only if, okay, I said y is gamma. Gamma 2 is going to be a closed curve if and only if gamma 1 is a closed curve, because again, if y1, gamma 1, why do I keep on calling it 1? If gamma 1 is a closed curve, aka gamma 1 of A is equal to gamma 1 of B, well then so is gamma 2, because gamma 2 of C is going to be gamma 1 of A, and gamma 2 of D is going to be gamma 1 of B. So this is basically if and only if relation. Alright, now this was the simplest part of the proof. Next, let's show that gamma 2 is an arc if gamma 1 is an arc. Well, an arc means that the curve is going to be 1 to 1. How do we show that? Well, phi is 1 to 1, and gamma 1 is going to be either 1 to 1 or not 1 to 1. So, first case, gamma 1 is 1 to 1. Well, then the composition of a 1 to 1 function with another 1 to 1 function is also going to be 1 to 1, and this is literally just gamma 2. So now we have a second case. Gamma 1 isn't 1 to 1. That means that there exists x1, actually no, let's call them x and x prime, such that gamma 1 of x is equal to gamma 1 of x prime. Well, recall how phi is an onto function. That means that for every value lying this segment AB, there is a value in the segment CD corresponding to it. And it's also one-to-one mapping, so those values do not overlap, so this implies there exists, let's call them t and t prime, such that phi of t is equal to gamma 1 of x. Okay, no, phi of t is equal to x, phi of t prime is equal to x prime. So as a result, we're to plug in to gamma 2 t, then it's going to be equal to gamma 2 t prime, because phi would result in x and x prime, and gamma 1 is going to result in the same mapping. Alright, so we have proven the arc part and the closed curve part. Now we need to show that rectifiability is if and only if thing, and that gamma 2 and gamma 1 are going to have the same length. Well, recall how we're to look into the length of two curves, and first let's define the length function for a specific partition. The definition for it is, well, the sum from I equals 1 up to n of the lengths of basically lines with the endpoints at xi and xi minus 1. And according to the triangle inequality, refinements of the partition are gonna be greater than the partition by length. So we can safely say that, let's call it P star, if it's gonna be a superset of P, then that implies that the length of P is less than or equal to the length of P star. Alright, cool. Now if we were to look into the definition of length per se, then this is just gonna be the supremum here. Okay, why did you actually remove this part? I don't need to remove it. So the length is gonna be the supremum of this. And it's denoted in a similar way, but without the partition argument. It's just the curve. So suppose that gamma 1 is not rectifiable. In other words, this supremum basically diverges. So for every m greater than 0 exists partition such that the length of the partition is gonna be greater than m. Alright. Now this implies that the supremum is plus infinity, so it's not gonna be a rectifiable curve. Now let's define partition 2 through the means of taking the inverse of phi. Recall how it's 1 to 1 and none 2, therefore there exists an inverse of it. And it's going to be phi inverse of xi for every xi. Alright, now guess what? The length of okay, first of all, I didn't specify the curve here. What would be gamma 1? The length of this partition 2 on gamma 2 is going to be equal to the length of partition 1 on gamma 1. Because if you were to look into this definition, then well, gamma 2 is just gamma 1 of phi of whatever value we paste in, and we were to take the inverse here of this part of the segment, we just get gamma 1 of xi instead of gamma 1 of inverse of phi, because we have phi stacked here. So we have this equality, and now this literally implies that for every m greater than 0 exists partition 2 such that the length of this partition on the curve gamma 2 is going to be greater than m. Alright, so what we have essentially done is we have shown that a non-rectifiable curve gamma 1 implies that gamma 2 is also non-rectifiable. Now, for convenience sake, I'll define a function here. I'll call this function, how do I call it? Let's call it theta of p Alright, thank you. Now, for looking into the problem of length, suppose that the length actually exists, so length of gamma 1 is less than plus infinity. Alright, now, what this means is that the supremum converges, and let's call this length L capital. Now this means that for every epsilon greater than 0 exists a partition such that the length of this partition on gamma 1 okay, and we subtract it from L because it's going to be greater. Again, it's supremum. And we get a value that's less than epsilon. Alright, now what we can do is we can define P2 as theta of P. And now we can say that L minus the length P2 gamma 2 is going to be less than epsilon. In other words, for every epsilon greater than 0 exists a partition 2 such that this thing is gonna be true. So the length of gamma 2 is gonna be equal to the length of gamma 1. This also implies that if gamma 1 is rectifiable, then so is gamma 2, because otherwise they wouldn't be able to share the lengths. So this is covered and this is covered. Alright, that's it. Hope it wasn't too lengthy.